Good evening, everyone.
Good evening.
Good evening.
Good
Good
evening.
evening.
Good evening.
Good evening.
Hello, good afternoon, everybody. Okay, so I'm trying to get the session to record before we start at 6 o'clock. Welcome. I put it to record, but I'm waiting for it to actually begin the recording process, right? So let's give it a minute, please. Excellent. It has started, right? So we can begin. So I hope you all will had a wonderful day and ready to do some maths now. Let's see. Let me just get this thing shared so that you all can see my screen. And we'll continue in the exact question we left off last day, the statistics question. Okay, we didn't get to finish the entire question. So we'll try to do that question today. So how are you all this afternoon? Are you all okay?
Yes, sir.
Yeah.
I'm fine.
Very nice. It's nice to hear some of the familiar voices again. All right, so no stress. Okay. All right, so I'm reading some of the comments. Nice to see you all. So I just made some. Okay, so remember this document from yesterday is the one we started. These are the questions we did. Now there are a lot of questions there, and what I decided to do is the same thing we did for the first day. How I uploaded the document with all the solutions. At the end of today's session, I will upload yesterday's document with all the solutions, even the questions we didn't do. Those are the ones that you could have tried. So you would see that all these questions have solutions. So this is one we did in class, but the one that you would have this is the one that you would have probably tried today. You would see the solutions are here as well. So you could easily go through the document, try the questions, the solutions are available. This is the question that we were doing yesterday. I edited the graph a little bit so that I could show you the point I'm trying to make. This is where we left off. So we did this work yesterday. We did the first parts of the question. We answered here. Is this one here that I was trying to explain, part B. So this is where we will continue the conversation, right? I made some slight edits to it, but I want you all to understand what this question is about. This question is functionally the reverse of a normal cumulative frequency question you may have done in school. You know, where they give you a table, you determine the cumulative frequency, and then you plot your graph and you answer questions based on the graph. That is a normal cumulative frequency question. However, this one, you notice they kind of give us a graph. And we have to use the information in the graph to fill out this table. And that can be difficult for some students. So let's refresh using the same content that I uploaded as well for you. Remember this thing I had prepared? This was our method. This is what I used to introduce statistics for this crash course. So when with regard to plotting a cumulative frequency curve, what you need to know is a few things. For example, we have these intervals, the class intervals here. We have upper and lower limits. We'll ignore the boundaries for this. We already looked at that yesterday. Now, let's say we have some frequency numbers. I hope you guys remember how to derive cumulative frequency from frequency, right? It was an easy method. We had derived these answers yesterday. Hopefully you all remember how to get cumulative frequency from frequency. You all remember how we did it yesterday, right? You all could get cumulative frequency from frequency. That's the easy one. You all hearing me? I'm thinking, well, right? Just testing my audio.
Yes.
You all hearing me? Right. So you all remember how to find
Yes.
cumulative frequency in general from frequency. So you just add 5 add 6 is 11. 11 add 8 is 19. Remember, I proposed a particular question yesterday. What if I have removed some of these values on the frequency column and asked you to use the cumulative frequency to fill in the blanks here? That is what the question that we are doing in the past paper is like. We basically have all the cumulative frequency values, but we are missing some frequency values, and we need to use the cumulative frequency to figure out the frequency. That is what we are going to be doing in the past paper. Okay, so that is what I'm going to continue it as of now. So I feel like it has no pause. I'll just continue directly from yesterday. I don't know. So what I've done here for you is I made a little sketch of the graph we had above. Notice this is a cumulative frequency curve. We have cumulative frequency on the y-axis, and we plotted it against the upper limit on the x-axis. This is our wonderful curve. Now, if we look at the information given to us in this column, let's look at the information. These are 1 to 10, 11 to 20, etc. These are our intervals. We have an upper limit and a lower limit. So in red, what I wrote here for you is I pulled out all the upper limits from the table. 10, 20, 30, 40, 50, 60. You see that? 10, 20, 30, 40, 50, 60 here. I pulled out all the upper limits. So that is the information that was given to us. They gave us the upper limits. Now, if I have a cumulative frequency curve, and I know the upper limit, let's say this upper limit, which I have a dotted line here, represents 20. Let's just use 20, okay? I can go up on my curve and across, and I can read off the cumulative frequency corresponding to the upper limit. So that is what you're going to have to do in this particular question. If you were to get this question, you would have to do that. You would use the upper limits in the table, go onto your cumulative frequency curve, and read off the cumulative frequency. That is how you look at the question, using the cumulative frequency curve, complete the table. So that is how you would use this cumulative frequency curve to help you complete that table. You need to find the corresponding cumulative frequencies for each of the upper limits. Let's see how we did that. Now, I already did it on the graph. I looked at each of my upper limits. We had 10, 20, 30, 40, 50, 60. And I read off the values, and I wrote down all the corresponding cumulative frequencies. So let me use this. Let me show you how we did it. So if we look at an upper limit of 10, let's find that on the graph. Let's go to the graph. So 10 minutes is the upper limit here. If we go up onto the curve, read it across, what value are we seeing on the cumulative frequency axis here? What are we seeing? We are seeing 12. Okay, so 12, I put that under this little column I made on the side here called cumulative frequency. So 12 is the cumulative frequency that corresponds to the upper limit of 10. If I move on to 20 now, let's go to 20 on the curve. We go upwards, we go across. 20 corresponds to a cumulative frequency of 34. And we keep doing that process for all. We don't need to really do it for all. You just need to do it in certain places to help you get your answer. But let's say you don't really understand it and you don't have that intuition in depth. I would suggest you get all the values and you draw a table basically like what I did here. So you go look on your graph for each one of these upper limit values, figure out the corresponding cumulative frequencies. So now we have a situation where and look at it, they gave us a few of the frequencies, but they are missing 2. These are the 2 that they are missing. So how now? No, so we could use the curve to get all the cumulative frequencies. So how do we go backwards now? How do we figure out the missing frequency values from this column, knowing all the cumulative frequencies? That is what you would have to do under exam pressure. You would have to figure out all of this what I explaining right now. That is what these students will have to do in that exam. So it's hopefully you would see that it's actually easy to figure out the missing frequency values given all the cumulative frequencies. Because in order to find cumulative frequency, remember, we take this number, we add it to the frequency to get the new cumulative frequency. For example, 12 add 22 is going to give us 34. So this missing value would have to be 22. Or you could say 34 take away 12 was 22. So we have to figure out what is the missing value all the way down here. How would we figure out this value? What do you think we would have to do to figure out this particular value in this curve here? Anyone has any ideas how we figuring out this value? Using the information I explained?
196 minus 84.
It wouldn't be 84. But you're good. You're using this value. So that's where you're good. You have this number 196 minus something. Let's see if anyone can guess it.
Minus 160.
Yes, it would be the 160. Because let's look at it this way. If we had known this value to get 196, you would take 160, add it to this value to get 196. But if you're going backwards, you just need to take them away from each other to get back this number. So what is 196 take away 160? What is that going to give us?
36.
36. So that is the missing frequency value there. 36. Okay, so this question is one that I would love for you. I hope some of you actually try to look at this question on your own. 36. Because this is actually a challenging question because it is, some people might enjoy driving forward, but they might have problem reversing a vehicle. I don't know, you all of age to have your license soon. That's a very similar analogy with maths. Some people like to do work in a particular order, but the minute you have to reverse that steps, that is when they get some problems. That is what this question is testing. Right? So now that we completed this column, how are we going to figure out what goes in these 2 empty spaces? What is the method we're going to use to fill these empty spaces? Let's
multiply the frequency by the midpoint.
Very good. And how do we know to do that? Because we look at the heading of the column. The column says to multiply frequency by midpoint. So frequency is F, midpoint is X. Multiplying F by X is what we're going to be doing here now. So what is 15.5? Well, midpoint times frequency is the same as frequency times midpoint. What is the product of these two numbers?
341.
341.
Very good. So that is easy. So it's how easy this question starts to become now. And what we would do the same for this one here. What is the product of 45.5 and 36?
1,638.
Excellent. 1,638. Now that we finished the table, you have to put 4 numbers in there to get the 3 marks. We could do the last part of the question now. The last part of the question wants us to use the information in this above table.
For where you put 31, it was 341.
30. Oh, yes. It's 341. My bad. Thank you. Right. And I'll see that in my notes as well. Thank you very much. Let me know. It is possible for me to make those little written errors. Thank you very much. So let's look at the question. Now, this question tends to trick students, but I see recently in 2021, and when you're doing the particular questions in this particular paper, you will see another question asking the same thing, the other statistics question I gave you. It's asking you to do the same thing that this part we are going on to now is asking you. So I would try to learn this particular formula that I'm going to give you that will help you with this question now. Huh? Keep that in the back of your mind for your exam because it came already twice, so it could possibly come again. So the question wants you to find average. Now, you all probably love to find average, right? So they want you to use the information in this wonderful table that we prepared. Let me try to get my pointer to show a little darker. All right, so they want us to use the information in the table above to calculate an estimate of the average time taken by the students to solve the problem. Basically, what they want here is the average from grouped data. How do we find average for grouped data in a table? Have you all ever learned to do that do you remember or have you all learned how to do that? Finding average for grouped data, let's say in a table like this. Did anybody learn this before? Or have any experience doing this particular type of question? How to find average like this in a table? All right. So for those who say
class midpoint, the frequency times midpoint, those answers added up together divided by 200.
That is actually perfect, right? That is correct. So that is the formula. Well, let's write out the formula for those who didn't do it. Now, this is a little obscure part of the syllabus that people tend to omit. So let's look at it now. So what we're going to do here is find the mean. You all know mean is another word for average, right? Mean. So I'm going to put mean because I'm not just write mean, right? MEAN, because I'm in the habit of writing mean now to represent average. So the formula that we are going to use in this question is equal to, mean is equal to the sum. So you could write the summation sign that looks like this. You all would probably see a sign looking like this. This is the summation sign. So the sum, let's write it in words though, sum of fx over the sum of f. What is fx and what is f? If we look at the graph, we have fx and we have f. In order to find the average from grouped data like this, all you have to know, you have to find the sum of all of these numbers and divide it by the sum of all of these numbers. That is why this table had this midpoint here and made you multiply the frequency by the midpoint. So you would use it to help you find the average of the data here. So what we have to do is add up all of these numbers. So I'm hoping some of you are already calculating this, or you have your calculators out, punching away at these numbers, trying to get the sum of all of these numbers we are seeing here. So what would be the sum of all of these numbers here? So let's write that.
6,320.
All right, so let me write that. So the sum, so I'm going to use the summation symbol, but they're looking too nice, right? So Right, the sum of fx is equal to what? 6,000. Can you repeat it, please?
320.
320. So we add up everything in this column, and this is what we got. Now let's add up the frequency. What is the sum of the frequency? This one should be easy. What is the sum of the frequency? Wouldn't that be the total students who wrote the exam? So the sum of f is equal to what?
People saying 200.
200, right? So yes, some of you please put on your mics and assist me, because I would not be able to keep going into the chat. So all we need to do now to finish this question is divide these two numbers. So what is, if we divide 6,320 by 200, what would that give us?
36.1.
31.6 or 36?
1.6.
31.6.
That's okay, 31.6. And what is the units for this? Anyone think about that so far, so far? This is what we are looking at, the average time taken.
Minutes.
So
Minutes.
time was measured in minutes, so the units would be in minutes. Don't forget to always include your units, right? 31.6 minutes. Right, and that brings us to the end of the cumulative frequency question. If I bring your attention a little lower now, there was another question, June 2022, question 5. And it's an easier question than this. This is the easier one. I don't know if any one of you tried this question because I had posted it with the documents yesterday. But if you did, your answers are available for you here, right? So you could look at this here. So there was this question. I wanted to point this out to you. They mentioned something called standard deviation. I just want to know, by switching on your mics, yes or no, have you all ever heard of standard deviation before?
No,
Yeah.
no,
So I got a lot of no's, okay? So let's look at what this is. Let's talk a little bit about what standard deviation is, okay? So I just want to, I'm not going to go through this question with you. You all could read my response and think to this question. But I want to just quickly spend 2 minutes talking about standard deviation for those of you who do not know about what it is. Standard deviation is a way we examine or observe how much a set of numbers vary from their average. Okay? It's a way we look at the spread of data. So if we have a large standard deviation, it means that the numbers were very far from the average value. If you have a small standard deviation, it would mean that the numbers are close to the average value. So standard deviation is something I still believe, this came in what year? 2022, okay? So if you don't know what standard deviation is, there's a lot of YouTube videos on it. So take down this as a topic that you should look at least a few videos on it. Now, this question doesn't want you to find standard deviation. They give you the value and want you to interpret it. So let me explain basically what standard deviation is. So for those of you here who are doing science, when you move on to Form 6, if you move on to Form 6, you will be doing standard deviation in biology and in chemistry, etc. Right? So this is something you will be doing a lot in the sciences. I will use a science example to explain standard deviation, but I will keep it simple to benefit all the other students who may not be doing science in Form 5. So let's just say we are measuring something, okay? We are measuring the length of a pencil, okay? Easy. Everybody could imagine you're taking a ruler and measuring the length of a pencil. So we have, let's say you measure the length. You as yourself, you take the ruler and you measure this pencil and you get 10.5 centimeters. Somebody else go to measure the pencil and they got 10.4 centimeters. Somebody who really probably don't know how to use the ruler good, measure the pencil, they get 10 centimeters. Right? So 3 people measure the pencil, they get 3 different values. What is the average of these values? Anyone could tell me quickly what's the average of 10.5, 10.4, and 10? Quickly, so that we could, I don't have actually, give me a moment to get my calculator. 1 second,
Somebody
please.
say 5, sir.
It'd be 10.3.
Yes. What is the average of it?
10.3.
10.3.
10.3 centimeters is the average. Isn't all these values looking kind of close to this average? 10.5 not too far off from 10.3. 10.4 not too far off from 10.3. And 10.0 not too far off from 10.3. So when you do something called standard deviation, it gives you a number. When you do a calculation for standard deviation, it gives you a number. The bigger the number is, that means that the values would have been very far from the mean. So let's look at a similar experiment. Let's look at this. Let's look at our next case. Let's say people measure in the same pencil. Somebody get 10.5. Somebody get 10.5. And the next person get the same 10.5. What is the average of these three values now? Isn't the average going to be 10.5? Right? 10.5 is the average. So if we're looking at this two set of measurements, hopefully you can see that the one on the right side here, all the values are basically extremely close or identical to the average. As in the other case here, they are a little different from the average. You're seeing that? Are you all seeing what I'm trying to say here?
Yes.
Standard deviation is a number. It's a number that you will calculate that would tell you how close numbers are to the average. If the numbers are very close to the average, as what we have on the right side here, you will have a very small standard deviation. If the numbers are very far from the average, this is not really far, but it's very far in comparison to the right set of information here, you will have a larger standard deviation. So, do you think you could understand generally then what standard deviation is without us doing any calculations? This is just a crash course, so I really can't go into how to calculate it for you, but I want you to at least be aware of what standard deviation is because they brought it in a question. So don't go into it. Most of you know would at least have an idea that it shows you how close values are to the average. Right? So that's it for the statistics portion. You can look at this question on your own. Right? This is the one we just did. Let me just scroll down. Right. So the next set of questions is measurements. Now, this is the question 6 on the paper. This is June 2021. Now, I did this question for you here. So you all could look at this particular question. This is one that I would have given you all to do. So I put down my calculation. So you try this question, compare your work into mine, and make sure you understand. Because this question could be a little difficult to visualize, I drew some diagrams here to assist. So those who did technical drawing might appreciate them better than the others. But give this question a try. These views here is that if you look at this is an eye, this is like if you're looking at this box directly above it. So they're literally looking into the box. So this thing that you are seeing here, this is literally the actual rectangle, the square thing you are seeing with the mouse is hovering over. And it is using I put dimensions in it, which you could zoom in and observe when you are practicing this question. Right, so I provided the solution for you. And I want us to do another question 6 here. So this is the one that I chose for us to do in class. So we're going to do this one together. This is June 2022 question 6. And we are about to begin this one, right? So let's start. This one shouldn't take us too long because it's a measurement question. Right, measurements shouldn't take us too long, hopefully. Okay, so let's see how fast we could do this question. So let's read it together. Well, let me read it for you. Can't read it together, I'm not in class. This diagram below shows a solid made from a semicircular cylindrical base, right? With a rectangular prism above it. What is another name for a rectangular prism? Does anyone know? A rectangular prism. Yes. a rectangular prism is also called a cuboid. Don't let the words rectangular prism scare you. This is simply a cuboid. Always remember that a rectangular prism is a cuboid. And below here, it comes like we have half of a cylinder. I don't know if you could visualize it, but this is like half of a cylinder below it, and above we have a cuboid. So the diameter of the cylindrical base and the width of the rectangular prism are 4 centimeters each. So that means, now let me show you, if this is a this here, what you are seeing is the diameter. This is like the, it's not looking like a circle because they're looking at a different view, right? A different view of the object. The dotted lines that you are seeing are hidden lines that is behind the object, and the solid lines are the lines that is in front that you would actually be seeing. So this below here is a cylinder, and the thing on top here is a cuboid. Now, the diameter of the cylinder, bear in mind, they say it's the same as the width of the cuboid, which is 4. So that means this diameter here has to be 4 centimeters. Okay, so that's a lot of useful information, right? Just knowing the diameter of the cylinder is very useful. So the first thing they want us to calculate is the total surface area of this solid. And they didn't leave it up to chance. They gave you some helpful information here. They told you what the surface area of a cylinder is going to be. All right, so they told you a little bit of the information already. They told the surface area of the cylinder, which has a radius of r, is this. Brother, it's not too complicated. Hopefully, it's not that bad. So let's see how I would handle a question like this. These questions are not as straightforward as previous questions that you would have done in the paper. Notice we are on question 6. From 6 go up, the questions start to use a little more skill. So you have to work a little harder now to get your marks. So what we can choose to do here is, remember, we want to find the total surface area. That means if we want to cover this whole thing with paper or something, we need to know how much paper to buy. So how much area of paper we need to buy if you want to paper this whole thing. That's just a kind of analogy. So in case you don't know what surface area is. Now I'm going to assume most of you here know what surface area is before we can actually begin. So if we're going to do this question, we're going to split it into 2 parts. We are going to find the surface area of the cuboid, and then we're going to find the surface area of the cylinder, and we are going to, the semi-cylinder actually, and then we are going to add them together to get the total surface area. That is the technique I would do. Okay, I think that's the only technique we could do in this particular question. So let's start by finding the surface area of the cylinder, because that's the harder one. Let's knock that one out first. So I would like for you all to be active and help me with this particular question, right? So let me start us off. Surface area of cylinder. Cylinder, that's not. Of cylinder, C-Y-L-I-N-D-E-R. They gave us this formula. For the interest of the question, I'm going to use 22/7 as pi. You can use the pi button on your calculator, but I would rather just use 22/7. If the diameter here of this prism is 4 centimeters, what is the radius?
2 centimeters.
Very good. So the radius here, we're going to be using 2. So every time you see r, we're going to be using 2. Where you see pi, we put in 22/7. And look at the h. What does h? What do you think h means in this formula? Notice it didn't tell you, so you have to know what h means. The height. So if we just look at the cylinder, just looking at the cylinder, what value you think we're going to be using for the height?
12 centimeters.
12 centimeters. Because if your height is the same, look at this, if you have a cylinder like that, that's the same value as if you lie it down on the side. In our way, the height now kind of comes like the width. Right? So don't let that word height scare you. They are just looking at the length, this full length of the cylinder here in this case. It's looking like a length here. But in reality, it is like a height. We are using 12. So now that we know the numbers that goes into this, do you recognize though that this is just half of a cylinder? I was seeing that it's just half of a cylinder we have here. It's just half. It's not the full cylinder. So if I go and put half in front of my whole working that I am about to do, I don't want that to confuse anybody, because we are not dealing with a full cylinder. We are only dealing with a semi-cylinder or a half of a cylinder. So let us begin. Right? I'm going to use a lot of brackets. I'll explain the brackets as we go along. Brackets are our friend in mathematics. So let's start. So area is equal to 2 pi r squared. So I'm going to write everything as fractions just to help it out a little bit. Bear with it. I will explain as we go in. So I'm going to put everything as a fraction for simplicity. So for 2, I'm putting it as 2 over 1 multiplied by pi is what? I'm going to use 22 over 7. What was the radius again? The radius we had said it was 2. Am I right? The radius is 2.
Yes, sir.
So if it's 2 squared, we could just put 4. But for the sake of students, if I put 2 over 1 multiply by 2 over 1, don't you recognize that this is still 2 squared?
Yes,
2 by 2 is still 2 squared. So
Yes,
I can
sir.
write it like that. It's not going to affect anything. That's my first grouping. That is this here we just wrote out. 2 pi r squared. 2 pi r squared. Now we're going to write plus, right? I'm putting my plus. And we need to fill out the rest. 2 pi rh. So let's put this in a new bracket. 2 pi rh. 2. I'm going to put everything as fractions just for this, because we deal with pi as a fraction. 2 times pi is 22 over 7. The radius was 2. And what did we say the height was again? We're using 12 as the height. Right? So we put in multiply by 12 as the height. Close brackets. This is what you need to calculate to get the surface area of the semi-cylinder. Let me just I want to color code everything. So this bracket is going to be in this color as well. Hopefully it wouldn't look too confusing once we put colors for everything and square brackets, etc. Get in the habit of using proper brackets. If we were to simplify this alone inside here, let me work it a little bit. I'm going to put back the half. I know some of you may already have an answer for me. But if I just work out what's inside here, what am I going to get? I am going to end up with, I put in the answer. Anyone wants to tell me? Anyone did it? Just this bit here? This works.
Over 7.
Yeah, well, this works out to be 25 and 1 over 7, right? So 25 and 1 over 7. Keeping everything color-coded so nobody gets lost. I put in my addition sign, open brackets. And if I work out everything here, that would work out to be, I will just write the answer here for you because I did this already. This portion will work out to be 150 and 6 over 7. Obviously, if you want, you could work in decimals. If you want to plug in this whole thing into your calculator, feel free. But I just working it in parts. A little bit in parts. So now if we work out what's inside this bracket again, 25 and 1/7, add 150 and 6 over 7. What would that give us? So again, you don't need to do all of this extra steps. You can work out this much faster in the exam, but I just want to have enough working for you. When you add up this together now, you are going to end up with 173. And what is half of 173? All you need to do now is find half of 173. And that works out to be a simple 86.5 centimeters squared. Very good, right? So this is the surface area of the cylinder. We just found the surface area of half of the cylinder. We still have to find the surface area of the cube, which is actually easier. because you all probably did calculate surface area of cubes since Form 1. So that one should be easy, okay? Well, not the cube, sorry, the cuboid. Yeah?
So when I work out 25 and 1 7 plus 150 and 6 sevens, I get 176.
176. Let me check it over here. Maybe I wrote it down wrong, right? 25 and 1 second. 25 and 1 over 7 add, right? 150 and 6 over 7. Yes, you are correct. So that's probably one of my little types. So thank you for double checking that. Right, so let's find half of this number now. So this is 176. Right, so we'll divide it by 2. It's 88. Okay, so we go with 88 for that. All right, so it's 88. 88 centimeters squared is the surface area of the cylinder. So let's find the surface area of the cube. How do you find surface area of a cuboid? Surface area of cuboid. Do you know what we have all the dimensions that we need? So if we look at this face here, do you realize that we have two of those faces?
Yes, sir.
So if you want to find the surface area of this cuboid, what is the surface area of this face? It will be 4 times. What is the length of the arm?
4 times 4.
4 times 4. Right? So this would be, and because we have 2 faces, I'm going to put 2 open brackets, 4 times 4. We could simplify it a little bit later. Right? So we're going on to the next side. Do we have 2 of these faces here? The front face, we have one in front and one in the back. So what is the surface area of this front face? How would we find that? That would be 12 times what? 12 times 4.
12 times 4.
Very good. And we have 2 of those faces, so that will be 2 multiplied by 12 times 4, which you could easily already be calculated for me as well. Now, let's look at this top face. What's the surface area of that? 12 times?
12 times 4.
But do we have to include it twice?
Yes, sir.
Yes.
Yes or no? That's a trick question, huh?
No.
No.
Because it's thrown.
This would be inside the object. So it would not be part of the surface of the object or the surface area. So do you understand that the top portion, we're not multiplying that by 2? That will just be add 12 times 4. Okay, 12 times 4. So this could easily calculate. When I worked out this, I had gotten 176. Did anybody get that?
Yes, sir.
So that's correct, right? I want to double check. So this works out to be 176. 176 centimeters squared. Make sure you put your units. So now that we found the surface area of the cylinder and the cuboid, to get the total surface area, TSA, total surface area, all you need to do is add the 2 values we just found. We add the 88 to the 176. All right, so someone add that for me and let me know what you get, please. 88.
264.
It's not
264.
it's not, again, a little difficulty to write here. Something is, it's not. Why am I not being able to write? Just 1 second. A little minor technical difficulty here. So let me see if I could write. Oh, no. All right. So let me just close this off and reopen it. Okay. So what was the answer for that?
264.
264. So you guys would have that, right? So crash course, that will be day 2, day 3, day 2. Right, solutions. Right, let's see if I will be able to write now. Some little glitch happened there. That's a little atypical. So let's see. Right, so let it open. But we had successfully found the total surface area of the shape now. For those who actually have the content, the next question wants us to find the volume of the entire shape. Okay, so now we're going to have to move on to finding the volume of the entire shape. Right, so you all said it was 264, right? I'm writing that quickly. Right, 264 centimeters squared. Moving on. Calculate the volume. There are two techniques you could use to find the volume of this shape. But the easier technique to most students is finding the volume.
Length times width times height.
Right, but that would be that formula is only how to put this? It's more useful for the cuboid portion we see in here. Let me remove all these scratches. I want to show you all something. In a prism, have you all ever heard that to find the surface area of the volume of a prism, you just need to find the area of like a face, a cross-sectional area, and then multiply that by the height of the object? Anybody ever heard of that? Or is that straight?
No, sir.
No, sir.
No?
Yes.
Well, some may have heard that. The science students probably have heard that one. But if you did not hear that, don't worry. We're going to do the other method. If I was going to find the volume of the shape, I'm going to find the volume of the cuboid first, and then find the volume of the cylinder, the half a cylinder, and add them together. Okay, and that is what we're going to do. Let's just do the easier method. So we're going to find the volume of the cuboid first, and then find the volume of the semi-cylinder. So that is what we're going to do. Now, do you all know that you don't need to memorize the volume of a cylinder? It's given to you in your formula sheet in the beginning of the paper. So let me just do some writing to find the volume. Volume, V-O-L-U-M-E. The volume of the shape would be equal to the volume of the semi-cylinder plus what?
Volume of the cuboid.
Very good. Volume of the rectangular prism or the cuboid. Very good. So because you may not have access, I don't have the formula sheet available right here for you to see. The formula sheet gives you the formula for volume of a cylinder. And the volume of a cylinder is given as pi
R squared H.
You're very good. Pi r squared h, which is basically area of a circle, pi r squared, times the height of the cylinder. Okay, in case anybody never made that connection, the volume of a cylinder is basically the area of the circle times the height. All right, so that's just a little extra. But is it a full cylinder we're dealing with or half a cylinder? Let me know.
Half a cylinder.
So I'm putting a half right here. Don't let that half confuse you. We have whatever the area is, we need to find half of it. So I'm putting that half one time into my formula. And we are adding this, okay? To the where to put that addition, where take a look too confusing, right? Here, I'm putting this addition right here. No, that's looking bad. I'll just put it right next to it now. We have to add it to the volume of a cuboid. What is the volume of a cuboid now? It's easy. Length by width by?
Height.
Very good. Right, so now we just need to plug in information and we'll find the volume. So for volume, I'm going to put half. Again, I'm going to use my little brackets, but I'm putting a half. Pi, again, I'm going to go with 22 over 7. You all remember what the radius of the cylinder was again?
2.
You could remember 2. Very good. 2 over 1. And because it's radius squared, I am putting it as 2 over 1 again, multiplied by the height. What was the height again? 12. Right. Close brackets. Add. What was the length, the width, and the height of the rectangle? Basically, it's 4 by 12 by 4. That will give us the volume of this cuboid here, 4 by 12 by 4. Okay, so I'm going to just put that in here. Plus, open bracket. Well, it was 12 by 4 by 4. So once you work out this bit of maths, we are going to end up with our area, our volume of our cylinder. What does this bit here work out to be? Can someone tell me? This first portion here. What does that? 88? You're sure, right? Let me try it as well.
Yes.
88, right? So I'm just giving, I'm using your values. 88. And what does this give us? 12 times 4 times 4. 192?
Yes, sir.
192. What is 88 plus 192?
280.
And what is the units for volume? The units for volume, because remember it's a volume question.
Centimeter cube.
Centimeters cube. Guys, you will lose marks.
Did you say 188 or 80? Oh, never mind.
Sorry? Is it working
I
out to
thought
be?
you said 188.
It's 188. It is, when you worked out, what did you get? 188? Sorry, I'm not hearing you well. Let me try it on my calculator. Right? A half times 22 over 7 times 2 times 2 times 12. And that gives me, when you guys work out this portion here, what did you get? You all got 88?
So I got
0.42 something, right?
Yes.
So that is actually that. So I don't know this is not 88. All right, so let's fix that. All right, so that is actually 75.429. Okay, so let's put it 75.429. This portion here still giving us 192. I believe that should. Okay, plus 192. And when we add them together, I'm thinking we should be seeing something like 267.429.
Yes, sir.
Yes, sir.
Right. Okay, so we're keeping it right. 492 or 429?
429.
Okay, great. So that's it for the volume of the solid, yeah. Right. So I will always be double checking as well. Normally I'll take answers from groups. Anyway, so moving on to the last part of this question now. The solid is made from gold. Right? So that's, imagine this shape. I just want you to imagine this is a golden shape now. So this is a piece of gold, okay? A solid piece of gold here. And what we're going to do is, let's see. They tell us that 1 cubic centimeter of gold has a mass of 19.3 grams. The cost of 1 gram of gold is $42.62. Calculate the cost of the gold used to make the solid. So this is an easy ratio type question. And let me start writing the solution. Keep your calculators on hand for us to do it. So let me just explain quickly. They gave you that a volume of 1 cubic centimeter has a mass of 19.3 grams. 1 cubic centimeter has a mass of 19.3 grams. So how would we find the mass of this volume on top here? What do you think we need to do? Remember, we know the volume of the shape. If 1 cubic centimeter has this mass, how are we going to find the volume for such a big amount? What do you think we're going to do there?
Multiply.
We are multiplying. That is correct. So because I did chemistry and I love chemistry, I am going to write sentences. You don't need to write it like this in your exam. But for those who do chemistry, you would know when you're doing these types of ratios, they just want you to write statements. You don't need to do it. You could just do the multiplication. But 1 centimeter cube has a mass of, what was it? 19.3 grams? 19.3 grams. Therefore, 3 dots does mean therefore, the volume that we calculated, 267.429 centimeter cube will have mass of, what would be the mass? We multiplying, right? We are going to multiply. So that will be 19.3 multiplied by 267.429 cm cube. What is that going to give us? If we multiply that, what is the mass of our shape? Anyone multiply that for me?
5,161.37.
Right, 5,161 point something, 0.38-ish, right? Grams.
Yes, sir.
Right, so that is the mass of our shape. Now, let's look at what it tells us. 1 gram costs $42.62. So how much would this mass cost? What we're going to do here now? Can someone tell me? If 1 gram costs that price, how would we find out how much? Could you speak up? I didn't hear you.
Take the 42.6 from the 5,000.
You want to multiply it or you say divide it? I didn't hear you there quite clearly. You said divide, right? Sorry, multiply. I think you said multiply. That is correct. If you said multiply, you just multiplying it by the $42.62. So I'm going to write a little statement again. I know that 1 gram of gold costs $42.62. $42.62. That is what I know. I'll take out this dollar sign for now, just to keep it simple. Therefore, the mass we just found, 5161.38, 5161.38 grams of gold. Let me fix that off a little neater for you all there. Of gold would cost $42.62 multiplied by the mass, which was 5161.38. You don't need to write all of these statements in your exam, but I am just putting this here so that if you're reading it, you will follow exactly what I did. So you will just see some maths and multiplications occurring. What is the answer to this question? When you multiply that, what would you get?
219,978.
$219,978. Look at the cost of that piece of gold. Right? So that is around the price that I had calculated here too. So that is correct. That is a very expensive piece of gold. Okay, so this is how you could expect a question 6 to look like. So when you expect, when you see a question 6, it's going to be not a basic measurement question. They are going to test your ability to use measurements, but at a little more depth, like what we saw here. For your practice question that you could do tomorrow, please try this one here. I posted this question 6 with the one with the box, and I already have the answers here for you, so you don't need to worry. Look at the question, look at my working, and you could come with questions for this one. If you don't understand my working, you don't understand something, come with those questions tomorrow and ask me in the beginning of the session. Right? Do we have any questions so far about these measurement type questions? They tend to be straightforward. Right? These tend to be relatively straightforward. Eh? So I'm saving this. This is going to be uploaded now at the end of the session. And what I'm going to do is I am moving on to the work that we have to do for today. All right, and today we are looking at how question 7 comes in a test paper. Question 7 tests you lean toward. Look at this pattern we are seeing here. We have this shape. It looks like a house. And then we have this shape that looks like 2 houses joined together. Then we have 3 houses joined together. So what would figure 4 look like?
4 houses.
Very good. So just give, yes, very good. So just give me a minute to sketch how that would look. Okay, so let me sketch that for you. So we'll have one house here. Now it's not gonna look perfect, I'm just sketching it fast. All right, so you all get the idea of what it's going to look like. So this is our next house, and the last house is going to be like that. Okay, make sure your drawing is done with a ruler and a pencil. Do not do something looking like this. This is just a sketch for you all to get the idea. Okay, when you're doing it in the exam, please.
So will we mark down for our drawings?
I believe if it's not drawn exactly like how they had these neat, they would misinterpret what you are trying to communicate. So I would think you should make sure you draw with a ruler and pencil here. It's not often they mark this, these papers marks you on something so easy. So let's not give them any opportunity to give the minus marks from you for this question. Okay, so this is 2 marks. You would have gotten 2 marks in this question for this. So let's read part B. The number of lines L in each shape and the perimeter P for the shape follow a pattern. Study the pattern of numbers in each row of the table below and answer the questions that follow. Complete the table below showing the number of lines and the perimeter of each figure. Okay, so that is what we're going to be doing. You don't even need to look at this drawing again. We just need to study the table as they said. They say study the pattern of numbers in each row of the table below. That's what they said here on top here. So we're going to look at, you all seeing the table by chance?
Yes, sir.
Yes.
Right,
Yes,
so
sir.
let's look at this pattern and see what is going on with it. Right, so just give me a minute to fix my pen and stuff, right? So again, a little technical glitches today, but I'm working around it. All right, so let's see. Let's look at each row. Let's focus on the number of lines, and then we'll focus on perimeter after. Let's do out this column first. So what is the relationship between 6, 11, and 16? Anyone can see a number pattern forming there?
5.
5.
Very good. We are adding 5 as we go across. Right, so we are right, so we are adding 5. Right, so you're all seeing that. We okay with that, right?
Yes,
It's a
sir.
simple pattern. We have 1, 2, 3, 5. Isn't it making sense that here would have 4? Even though that's not part of the
Yes, sir.
question?
Yes,
So-
sir.
So even though that's not part of the question, students might just choose to put a 4 there. Now I will show you the easy way to do the question after. Right? But students might instantly start doing this question exactly like this. This is how students might start the question. So they will say, okay, 4 will be, you'll have to add 5 to 16. What is 16 add 5?
21.
21.
Right.
21.
And to get this missing number here, what they're going to do now to the 21? You'll add 5.
Add 5.
And you'll get 25. So students will be very happy. But you see when you reach here now,
Sir, it's 26.
21 add 5 is 26. Very good, right? True. But the point what I'm trying to make is when you reach down here, you see the problem now? You're going to sit down and spend a lot of time adding 5 until you figure out what number corresponds to 66. So can you see that this is not the most efficient way now of doing this question? A lot of you would have probably did this up to this point. I believe so. You would have started this question, figured out the pattern, and when you reach 66, your head would start to hurt, and you'll be like, nah, boy, I don't need that marks. Right, so let's figure out a better way to do this question. So I'm going to erase these little plus 5s because it is getting in my way. I'm going to erase this as well because I don't need it. We could leave this 26 here because that is our answer. You will get marks for. Let's look at this, however.
To find the M formula first.
Very good. That is true. We could figure out a formula. This one down here. Now, in honesty, when I first saw this question, I came up with a formula, but I don't want to confuse students with the algebraic way of the formula. So let's just use a common sense approach to the formula. Firstly, let's look at 6 and 11. If I say 1 times 5, add 1, am I going to get 6?
No,
Check
sir.
it.
Yes, sir.
Yes, 1 times
Yes,
5
sir.
is 5.
Yes,
Add 1
sir.
is 6. But must say use the brackets first. Now, if I go to 2 times 5, add 1. 2 5s are what? 10. Add 1 is 11. So now if I go down to 3 now, 3 times 5, which is 15, add 1. Am I getting 16?
Yes, sir.
Yes, sir.
Very good. So that is the number pattern. And we will
Excuse me, sir.
tidy it up. Yes. Yeah.
Sorry. The
Mhm.
numbers that are on the figure. Sorry, can you please make it the chart big?
The chart like this here, or do you want to see the whole
No.
chart?
Yes, sir. Sir, the numbers that are under the part that says figure, you're just multiplying it by
This one,
the
I'm trying
number
to
that was given.
I'm not following what you're saying. So let me try to understand that question. So where you see figure written, figure here, right? Yes, that is what I am doing. So I am taking these numbers, multiplying it by 5, and then adding 1 to it to make these numbers 6. That's what you were trying to clarify?
Yes, sir.
Yes, so that is the pattern. You would actually realize that now when you come up with the pattern, how we getting 6, 11, and 16, you would say, but wait now, look at that. This 1 is that 1, this 2 is this 2, this 3 is that 3. And that is what's going to help you figure out this missing number down here. So let's see how we could use this number pattern now to figure out some information. So let's look at this 5. If we want to figure out this number 26, I would have just put 5 here, multiply by 5, which is 25, add 1, and that would have given me my 26. So you see my pattern is holding true. So let's continue with the pattern. But at this point down here is where we still need to figure out this missing number. So let me show you how I would figure out that number. Remember, we don't know that number, so we could call it X if we want, if you would like, for now. So we know that if you have X and you multiply it by 5 and you add 1 to it, you are going to get 66. Can you see that this is basically an equation which X is the only variable? Let's shift the same thing. I hope you all see this. Remember, this number here is always the first number. This 3 is this 3 here. The numbers are, that's how we, that's the pattern we are seeing. So we just need to figure out X in this equation, and we would solve for this missing thing and this missing
Sir,
portion.
could we divide 5 by the 66?
5 by, okay. Let me do let me show you how to do this calculation, and then I will check that for you, okay? Because if you divide 66 by 5, we'll end up with a fraction, and we would not get a fraction here, okay? So let's look at how to simplify this. I'm going to write over that equation here. All right, so let's write it over. It was X times 5 plus 1 equals 66. Do you all agree that X times 5 is 5X?
Yes, sir.
Yes, sir.
5X plus 1 equals 66. This is a simple equation we need to solve for X for. Simple as you could ask. We could move this 1 across the equal sign, so we ended up with 5X is equal to 66, take away 1. So what is 5X therefore equal to? What is 66 take away 1? 65.
5.
So how do we find for X? What could we do?
Divide 65
Divide by
by 5.
5 on both sides. Very good. So you get X equal, what is 65 divided by 5?
13.
13. So we now know that X is equal to, X is equal to 2. Just 1 second. Right. X is equal to 13. So that is how we figured out this value as 13 there. And the general formula for n is the same thing we just did there. Right? So what you could write now for your general formula is instead of putting x, you could put n. So it would be n, right? N times 5 plus 1. But isn't n times 5 the same as 5n?
Yes, sir.
So you can remove this and just replace it with a 5n. So the pattern is 5n plus 1. And that helped us fill out a lot of information here. We have to do, yes?
Would you lose marks if you leave 5 by n?
No, I don't think you should. That is still acceptable, right? I don't think you should because it is still correct. So now we're going to do you see what we did for here? Let's do it for the perimeter portion, but because it's the same thing you're going to be doing again, let's see if we could do it a little bit faster. The first thing you will have to do is identify the pattern among these numbers. What is the pattern here? What's the pattern between 5? You're very good. Between 5, 8, and 11, we are method here now. Look at this. If I put 1 times, let me use a 10 point, right? 1 times 3, add 2. Am I going to get 5? 1, 3 is 3, add 2 is 5. Let's see if it holds. The same thing we did. So the next number we're going to put is 2. 2 times 3 is 6. If you add 2 to 6, are we getting 8? Yes.
Yes, sir.
Let's move on and test it again. 2 times, sorry, not 2, 3. Moving on to 3. 3 times 3 is 9. Add 2 is 11. So you all see that this is following us a pattern, again, that we can easily work with. Now, we need to figure out this missing number. How do we do that? We have this number as 5. So it would be 5 times 3 plus 2. What is that going to be?
17.
17. Okay, so that's not hard, hopefully. So this number is 17. Okay, so we okay so far? Let's move on now to here. How are we going to find this number? Don't we already figured out that this is 13. So we just put 13 by 3, add 2. That's all. 13 times 3, add 2. What is that going to give us?
41.
Very good. 41. Moving on. We just need to come up with the general form here now, like what we did before. What would be the general form of this one? Let's see if we could figure it out together.
N times 3 plus 2.
N times 3 plus 2. And isn't n times 3 the same as 3n? N times 3 is 3n. So you could just keep it simple as 3n plus 2. All right, and that is the end of this table, this wonderfully challenging table. So, with that being said, let us move on to the last part of the question. Is this rather simple? It requires you to have a little bit of algebra background, but notice a lot of the algebra you're going to encounter in your paper is solving for a variable, like what we saw here. It was important that we had solved for that variable because that 13 helped us here in the perimeter portion. All right, so this wasn't that bad. Let's look at the last part of the question. Now, the last part of the question, write a simplified expression in terms of n for the difference, d, between the number of lines and the perimeter of any figure, n. This question, the key word is difference. What does difference mean again?
Take away.
Subtract or take away, right? Very good. And they want you to find the difference D. So I'm going to write D here. The difference D will be equal to something, right? That is what we're trying to find. D will be equal to something. And it says the difference between the number of lines and the perimeter.
So if you're going to take the lines from the perimeter?
Yes, you are taking away these. So basically, yes. Look at this, number of lines and perimeter. We have, and if you look at the question again, they want us to use the N that we just figured out here. So we are basically going to take away this expression from this expression. That is all we are going to do. It's nothing more complex than that. 5n add 1 or 5n plus 1, take away 3n plus 2. So let's do that. 5n plus 1, take away 3n plus 2. Do we leave it like this? Yes or no? As in, no. We have to simplify, yes, but do we just leave it? What is the problem here? What are we missing?
You're going to put the like terms on one?
So we can group like terms.
Yes, we have to group like terms, but remember we saw a situation like this a few days ago, I think on the first day.
Sir, when they bring it over, the subtract?
Yes, subtraction sign is effectively going to change this sign, and if you don't put this in brackets and you group them without knowing the implications of the subtraction sign, you are going to get the wrong answer. This, you remember, you are taking away the first expression from the entire second expression. That's why we put it in our brackets, to imply that everything in here is being subtracted by everything here, by the first expression. Whatever the first expression is, we are taking away the entire second expression from it. That is why the brackets are important. Okay? Brackets are very important in these types of questions. If it was an addition sign, to be honest, guys, it wouldn't matter. But once you see a subtraction sign, please use your brackets because it's going to change things. Because if we distribute, now if I put this as -1, that should not be too confusing, hopefully, because it's an expansion that needs to be done to cater for these brackets that we put. So let's do this expansion. Notice the D equals to 5n plus 1 is not being affected by this. But what is -1 times 3n? What would that give? -1 times 3n would give?
-3n.
-3n. And what would the -1 times +2 give?
-2.
-2. So this sign had changed. And if you had not put your brackets, you wouldn't have catered for that and you would have run into problems. So now that we have this here, we could group like terms. So let's group our like terms. So what are the like terms?
5n and 3n.
So how do we write it? 5n what? What are we putting there?
-3n.
Very good. And then what else we put in? Tell me. Let you all tell me. All right.
1 plus 2.
1 minus 2.
Very good. +1 minus 2. We grouped terms. Notice nothing moved across an equal sign, so no signs are changing. We are just rearranging the furniture. Okay? What is D would therefore be equal to, what is 5n take away 3n?
2n minus 1.
And +1 take away 2 is -1. Use a calculator if you cannot do this. Don't listen to me. There's no shame in using your calculator. That is why you have it for. Use your calculator for directed numbers if you are having difficulty. I guarantee a lot of you who, let's say you write this exam and you don't get the grade you want, the reason is not because you didn't know you were working. The reason is because a little directed number caused your answer to be wrong and that puts down your grade. Use your calculators for directed numbers if you're not confident in your ability. Okay? So that should be, this is the answer then. D is equal to 2n minus 1. This is a expression that represents the difference between the lines, the number of lines, and the perimeter of the shape. That's the end of this question. Right, 10 marks. That's the end. We could celebrate that we have finished a question 7. So what does that mean? How much more questions do we have to do in the paper before we finish a paper 2?
3.
And you know what to expect coming up now, okay? The next 3 questions are not going to be the kindest. So question 8 is going to be an inequalities question. Question 9 is going to be circle theorems and bearings. Question 7. This is a pattern question I want you all to try. It's a very similar question. You have a very similar table to figure out the pattern and fill out. And I'll post the solutions for this one by tomorrow night. Okay, when I'm doing this one, I'll give you all the solutions for this one tomorrow night. So you have one to try for tomorrow. Look out for the answers for that one. So no one can tell me what the last question on the paper has in it?
Matrices and vectors.
Matrices and vectors. Right? Vectors and matrices. Now, long ago, it used to be an option, but now I think it's certainly compulsory. So let's try to make sure you get those marks, right? So that is what we're going to spend in tomorrow's session. We are going to go heavily on vectors and matrices and circle theorems. And that's the last session. And we will do some past paper, some multiple choice as well tomorrow. Eh? But today, let's see if we could at least do question 8. In my opinion, from observing how students do in these types of questions, students tend to get circle theorem questions wrong, but I believe like the frequency of students getting question 8 wrong is higher. This is a question students get wrong a lot because these types of questions really requires you to understand how to draw graphs, how to draw lines on graphs without giving your points. You have to figure out points on your own, etc. And inequalities, which is something that students have a little difficulty understanding and wrapping their minds around the concept. For that reason, if you have no idea what an inequality question is, you might have a little difficulty processing what we're going to do in question 8. Because remember, I'm not really teaching the topic entirely. We're doing a question reflecting the skills on the topic. So let us take our time in analyzing this question. We're going to spend the rest of the session doing this one. And if we finish, we could do piece of the circle theorem question. Right? That is what I want us to do. But let's see how much of a number 8 we can do. So let me know, are you strong or weak with, how do you feel? Be honest with yourself with inequalities. That is the topic we're going to be doing here now. Inequalities. What is how strong are you in inequalities? Let me hear. How do you feel?
Strong. Weak.
I never like this topic, huh? So,
in between.
Yeah, so it has some basic concepts that I hope you all kind of remember. Like if you divide by a negative number, you change the inequality sign. I don't know if those things are familiar things. If you have difficulties with inequalities, I have a document here on how to graph. This is not a document, it's a website that I find was very useful on how to graph inequalities. That is what this question is testing. So I will put this link for this thing. You all can read it through. It's not too much. It's actually not too much. It's a small document, and it's very useful in explaining how to graph inequalities. Okay, so if what we do today for the rest of the period is a little difficult, and you all get a little difficulty understanding it, especially the graphing portion, please look at this document. It is going to be very useful. Now, I will post a link for this on the course shell at the end of the period. Hopefully I remember, right? I should remember. So let me go now and start the inequalities question without any further ado. This is the last question I'm most likely we're doing for today. It's already 7:20. So let's see how much we could do. So let's read the question. Marla buys, look at the names, right? 2 types of mobile phones, B Flow and C Flex. from a company to retail, meaning that this girl buying some phones in order to sell over. So she probably trying to buy plenty phones to make money off. That's what she's trying to do. But when you want to see retail, think about the fact that she's trying to sell it back for a profit. Now, one B-Flow mobile phone costs $60, while one C-Flex costs $80. She buys X number of B-Flow and Y number of C-Flex phones. Already here, they gave us what I like to call an exposition dump of information. Let's start doing something with this information before we even read the question. And the first thing I would do is, because it told us explicitly what X and Y is, I will put, and I'm seeing these two words nice and big and bold here, I am going to write, because X is the number of B-Flow, I'm going to put an X here so that I can always quickly refer to this and visually see it. So that if I'm getting confused in the question, I know X is the number of B-Flow phones, and Y, where's my, Y is the number of C-Flex phones. That is the first thing I want to do. Okay, so that will kind of help me home in to this question. So again, there's X is the number of B-Flow, Y is the number of C-Flex, and they gave us the cost. So which one costs more? Which of these two phones costing more? C-Flex is costing $20 more, right? Just keep that in the back of your mind that the C-Flex phone is a little more costly. Now, let's read the question, part A. Marla must not spend more than $1,200. Write an inequality to represent this information. She must not spend more than that amount of money. So, what we're going to... Sorry about that. What we're going to do here is, let's read and piece together this puzzle. The most she could spend is $1,200. And they said she bought X number of B-Flow phones. Okay, so if each B-Flow phone costs $60 and she bought X amount of B-Flow phones, then how much would she spend on B-Flow phones? When she spend 60X, she bought X number of B-Flow. Each B-Flow is $60. So 60 times X would have given us 60X. Right, so that's the first thing. We didn't finish yet. 60X is basically the cost of the B-Flow phones. What would be the cost of the C-Flex phones? She bought Y number. Yes, 80Y, because she bought Y number of the C-Flex phones, and each cost $80. So if each phone is 80 and she bought Y amount, the total she would have spent there is 80Y. So far, we okay with this? Hopefully nobody lost. Sir. This is the easy part. And the condition is that she must not spend more than $1,200. What does that mean? If you have a condition that you can go out and buy stuff, but you cannot spend more than $1,200, what does that mean to you? That means what?
Less than or equal to.
Yes, it means you could spend less than $1,200. You could spend $1,200, but you cannot spend more than $1,200. You could spend less than $1,200, or you could spend $1,200, which is less than or equal to. So you have to write the symbol for less than and equal to here and put 1,200 next to it. Are we okay with this? This is the less than or equal to symbol, by the way. Are we okay with this? This is the first part.
Sir.
Yes, sir.
Yes, sir.
I'm hoping we're good. This is I want you all to take it in. This last half an hour going to be a little difficult. I'm telling you all, because this question, inequalities, is a difficult topic for students. So I want you all to keep working this with me and communicating with me. Those who it's only recently I remember in students are on the YouTube link. So if you are on the YouTube link, and anybody monitoring it, just let me know if you have any questions. Somebody read the questions for me, right? So let's continue. Part 2. The number of B-flow phones must be greater than or equal to the number of C-flex phones. Write down an inequality in X and Y to show this information. So let's read that again. Because the first time I read a question, I don't know about you, but like it just go through my head somewhere, and then I had to read it over a few times to really understand it. So let's read it over again, right? I am doing like if I've never read the question before. So the number of B-flow phones must be greater than or equal to the number of C-flex phones. Remember, they gave us the number of B-flow and the number of C-flex. That's X and Y respectively. That's why I wrote them on top here. So in other words, B-flow is X, right? C-flex is Y. X, it must be greater than or equal to. So you just need to put X, the symbol for greater than and equal to. What is the symbol for greater than and equal to? This is the greater than symbol, and this on the bottom means it's greater than and or equal to. And you'll put Y. That is your answer. Are we okay with this one?
Sir, so why wouldn't you put back the 60 and the 80 beside after that?
Right, because this question, the 60 and the 80, involves money, because that's the cost. You see the 60, these are dollars. These are the costs of these items. This question below here does not deal with the cost. It's just looking only at the number. Let me see if I can, tell me if you see it.
Can I ask, sir? All right. For instance, we got that question and we were asked that question. If we put 80Y and 60X, would we get that wrong?
Yes, you would, because by putting 80, you are talking about, you are including the cost of the phones. You are given an inequality based on the cost of the phones rather than the number of the phones. Because the number of the phones is different from the cost of them. So that is why it's important. We have to understand exactly what they are asking. So they say, that's why, let me show you again how I would do it. But it's a good question. That's a really good question. So let's read it again so that we make sure we understand why I did this. The number of B-flow phones. And if you go here, they said she buys X number of B-flow phones. So X is the number of B-flow phones. So the number of B-flow phones, which is X, must be greater than or equal to, which is the symbol, the number of C-flex phones, which is Y. Because it didn't include anything with money and cost, I did not include the cost of these phones. I only stuck with the numbers of the phones. Are we okay? Do you all think you're following why I did not put the 60 and the 80? That's a really good question. I like how somebody asked that question, right? That question really helps me to further explain this thing. So hopefully we're good. Let me know. Can we move on to the next part, which is actually the challenging part of the question?
Yes, sir. Yes, sir.
Right. Now, this is where things get a little difficult for us, because if we read the next question, without any more build-up, they throw this on us. Represent the two inequalities on the grid shown below. Label as R the region which satisfies both inequalities. Show of hands if you think you could do this. Well, actually, I can't say show of hands because YouTube. Switch on some mic and be honest. Let's be honest. If you all think you could do this one. Okay, put on your mic. Do you think this would fumble you a little bit?
Yes, sir.
Yes, sir.
I find like this was unexpected. Like they could have built you up to this question, but it's not going to be an easy way to get to this answer. All right, so let's do it. All right, so we had no build up to this. We just need to dive into the question. So they want us to represent these two inequalities on the graph paper. By you just looking at these two inequalities, where would you draw these inequalities? How does an inequality look? So, spoiler alert, right? An inequality is basically a line like this and a shaded region below. Right? So inequalities could look so much different ways. We have a line and a shaded region. I am uploading this document for you. so that you would remember what this is. Not upload, sorry, I'm sharing this link with you. This is how to graph inequalities. Isn't that what we're going to do here now? What we're doing now is graphing these two inequalities. We have to draw them on a piece of graph paper, right? Let me just close off this document, please, because it's drawing some system load, right? Right, good. So let us graph these inequalities. Now, there's a mistake in this graph paper. Now, CXC doesn't really make mistakes, but they did make a mistake here. And the mistake in this graph paper is the scale on the y-axis. If we look at something carefully, we have how much boxes between 0 and 5? We have 1, 2, 3, 4. Again, between 5 and 10, we have 1, 2, 3, 4. Between 10 and 15, we have 1, 2, 3, 4. But between 15 and 20, we have 1, 2, 3, 4, 5. So there was a mistake in this paper. I don't know how they would have catered for that for marking letter, but I don't know how they would have catered for that. But we're not going to follow suit with their mistake. So I'm going to just make a little edit here and put that as 20. Okay, so let's actually just erase that whole thing. Right, that's just going to be 20. Right, so we fix our scale before we go to attempt the question. Do you all understand that you all saw the error that they had, right? You all understand the error I mentioned here? They put an extra block by mistake. Okay, yes, that would have probably confused so much students back in the day, in 2022 or whenever this exam question came out. So let's look now at how we would handle this particular inequality. When you are going to graph an inequality, do you realize, even from this thing here, inequality is basically, it has a straight line in it? A straight line. Don't we kind of know something about straight line geometry? We know a little bit about straight lines, right? I think we all should remember a little bit about your straight line geometry. We did a question on it actually yesterday where we had the perpendicular lines.
Y equal mx plus c.
Y equal mx plus c.
All right, so that is good. Now, there are multiple methods you could use at this point, and I'm going to use the easier method, but I will mention something to you. Right, so what you're going to do in questions like this is you see the inequality symbol. We kind of don't really, for the first part of it, to get the straight line, we ignore the inequality symbol and consider it as an equal sign. So let me do some work in here. So we're going to deal with this first equation, 60x plus 80y, and we have 1200. So I'm going to write that here. That was 60. Let me write it a little smaller because it's going to be a lot of work. 60x plus 80y. And remember I told you, we're ignoring the inequality symbol. We put in an equal sign for now, and we put in the number there, 1200. 1200. What we want to do is graph this. This is going to give us a straight line. What you can do is rearrange this into the form y is equal to mx plus c. That might help you to visualize it better. But there's an easier method you could use. And when there is an easier method you could use. And I don't know if you all are familiar with these things. So I'm going to ask you all. If you have a line like this is a line, an equation for a line. Do you know how to find the y, not looking at the equation, a method to calculate the x and the y intercepts from it? Do you all know how to get the x and y intercepts from this line? A calculation to do it? No, yes.
No, sir.
No, so let
sir.
me show you how to do it. Okay? So when you have an equation of a line, in order for us to plot this on this graph paper, what I want is, let's say I could figure out the y, this is the y-axis. You all know this one down here is the x-axis. If I could figure out the y-intercept, and let's say I could figure out an x-intercept or some sort, I will have 2 points that I could draw a line to represent my equation or inequality. So that is what I'm going to do. I want to figure out where that line is going to cut the x-axis, and where it is going to cut the y-axis. That is what I want to do. And to do that, we have to do 2 small, easy calculations. And this is something that you should try to remember for the sake of your upcoming exams. So in order to find, let's do the x-intercept first, okay? Or the y. Let's do the y-intercept first. So I'm going to write it here. Remember this, I'll write it out a little bit. To find y-intercept, okay, we're going to set x to be equal to 0. So what does that mean? That means in the equation, 60 x plus 80 y equals 1200. I am going to replace the x with a 0. You always will do this in order to solve for your y-intercept. It's a technique that we use to quickly take an equation and find the y-intercept. So let's try to see if we could solve this and figure out the y-intercept using this condition. 60 times 0 is 0. What is 0 plus 80y? Isn't that just going to leave us with 80y equals to 1200? How do we find y?
So we divide by 80.
Very good. We divide it. So I'm just going to write it like this. Y will be 1200 divided by 80. What does that give us?
15, y equals 16.
Very good. Now let's look at something. Now I want to point out this to you. This is going to give us the coordinates of the y-intercept. We know that x is equal to 0. We're seeing that here, and y is equal to 15. So I'm going to write that somewhere here. I'm going to just put it in here, right? X, the coordinates of this first point now on this graph, for this line, will be 0, 15. So where is this going to be on our graph paper? It will be 0 on the x, and we'll go up to meet 50 the y. So where's 15 on the y? Isn't that this 15 here? So let me just put a dot right here, and we'll come back to this very soon. So you all understand what I did there? All I did is I used this very simple, in my opinion, it's a simple condition that we could quickly use to find some points to plot these lines. You could use it for any equation, any line. Once you know it's a line you have to get, and you don't know what is 2 points for the line, you could find your intercepts. It will really assist you. So what we did is we find the y-intercept. What the next thing we're going to find now is the x-intercept. We have to find the x-intercept as well. So watch how to find the x-intercept now. So I'll write it here, to find the, look at the time. I don't know how time just creep up already. The x-intercept. Sorry, can you please repeat that?
Set y, the y-intercept equals to 0.
Very good. Yes, you know it. Excellent. So to find the x-intercept, you set y equal to 0. So you see how easy that is? When you want to find the y-intercept, guys, like what we just did, you make x equal to 0. Well, when you want to find the x-intercept, you do the opposite. You let y equal to 0. That is really an easy way. Once you have a line, to get 2 points that you could use to plot your line on a graph. I feel that's an extremely easy way. Right? So let's find the x-intercept now. So I'm going to write that equation 60x plus 80y equals 1200. Let me quickly write that. 60x plus 80y equals 1200. So what are we setting to 0? Y. Right? So let's set the y equal to 0 now. So we'll be left with 60x plus 80 times 0 is equal to 1200. And what is that giving us? 60x is equal to 1200. So how do we find for x? X will be what?
1200 divided by 60.
1200 divided by 60, and that will give us, somebody said it just now? 20. So what will be the coordinates of the x-intercept? We know that y is equal to 0 and x is equal to 20. So that is the coordinates of our y-intercept. So would we put the 0, 20, or would we put 20, 0? Remember,
0.
Very good. Because you must remember your x is always written before your y, right? Always put x before y. So now we have the coordinates of the x-intercept. So we just need to find 0, 20 on the x, 0 on the y. So that would probably 0 on the y, 20 on the x is going to be this corner here. Oops, let's make that bigger. Right. So now we have 2 points. So what do? What can we do? We can draw lines. Now, I don't have this app I'm using, unfortunately, doesn't have straight lines. So we're going to have to live with this when I draw it, right? So let's just work with this line. It's not going to look the best, but I will laugh at it, right? We're going to just try something. Oh God, nah, that's too thick. Right, so that's one. I need to get a way to get straight lines with this. Right, so let's just use it. Right, so that's the best I could give already. Right, so a roughly a straight line. So that's the first thing we did. So we're already working through this. Now, I use up all the space here, but we still have to plot the second inequality. We didn't plot that yet. Right, so we're going to plot that one now. Believe it or not, this one easier to plot. And I could show you how easy this is to plot. So, remember, when you are plotting an inequality, when you want to draw your line for it, you use an equal sign, firstly. So I'm going to just work in this little corner up here, right? I'll work in this little corner here. Look at something. If I remove the inequality sign and put an equal sign, what would I be left with? Wouldn't I be left with x equals y?
Yes, sir.
So how would that look on our graph paper? Let's come up with 2 points. Let's just say if x is 2, what would y be? 2. If x is 3, what would y be?
3.
If x is 20, what would y be?
20.
20. So you see, that might not be that difficult to plot. So when x is 1 here, y will also be 1. So that point will be here. When x is 2, y will be 2. So that point will be here. And you're noticing what the trend will be, huh? You're going up like that. So let me just put 1 point, and I'll just use 15. So when x is 15, y has to also be equal to... No, this is a little difficult to draw. So what I'm going to do is just continue the trend, right? Because I don't like the scale. They use a really ridiculous scale over here. So let us just draw this line. We have enough points to draw the line. Do you all understand how I got the points for this line? I use this easy intuition that when x is a number, y must match that number. So in other words, let's say when x is 10, y must be 10, and we'll have a point at this point here. So if we remove the ones in the middle, we have 2 points. We could use it now to draw a line representing that that equation. So let me draw this line. You all understanding so far? Let me know. A little feedback, please. Anything?
Yes, sir.
Yes, sir.
Right. So I just drawing it like that for now. It wouldn't be the best. You will have to use your rulers and stuff in the exam room, and it would probably cause your lines to meet at a little different point, but it's an estimate based on what we're doing here currently. So this is what we did so far. We represented 2 inequalities on the grid, but what we didn't really do is represent inequalities. What we did is represent lines. So on each line, I am going to write the inequality. So the one that went down, that was the first one we did. That is 60x plus 80y equals, well, I'll write it in. Let's write it. That was 60x plus 80y. And I believe, what symbol did we have there? I just finished populating the thing. That is less than and equal to 1200. Less than and equal to 1200. Less than and equal to 1200. And this line we just drew up here was the line of x is more than or equal to y, right? So let's just put in that here. X is more than or equal to y. So now I label my graphs. Now, if we look at this website that I was showing you, when you plot an inequality, you must shade a certain region. So now what we have to do is for each line and each inequality, we have to shade the correct region. And there are ways there are calculations you could do to help test which region you would shade. Now, generally, people would just, when you see less than or equal to, they tend to shade the bottom regions, okay? And that's what they tend to do. But I want to show you all a way we could test which region we could shade here, because we have to figure out where to shade. So if in case you don't know what I mean by shade, let me show you quickly. What I mean by shade is you can either shade below the graph, or you can shade above this line. You all get the idea? We're talking about this particular line here. You can shade either above or below. But how to tell which side to shade? Let's look at a way we could figure out precisely what side you could basically shade. So we have a wonderful inequality. 60x plus 80y is less than or equal to 1200. If I were to take any point below this, that point will have an x and a y value. If I were to substitute the x value here, the y value here, this answer on the left must satisfy this inequality. It must be less than and equal to 1200. If we do that test, we'll be able to figure out for sure that the bottom portion here needs to be shaded. If it fails the test, it means that the top portion must be shaded. So it's up to you to pick any point that you want to pick. You can pick any point, any coordinate point down here that you're seeing. That's up to you. So let's just pick a point here. So the easier points to pick would be something that has a 0 in it. So if I pick this point, I want you all to pay attention. And this is where you could get lost. If I pick this point here, do you agree that this point is below this line? We're talking about the line that slants in that direction. You all agree that the point which I had drawn below initially there, this point down here, that is below the line, and you all can see that point is below the line.
Yes.
So if this point tests true, then we shade below the line. So let's look at what that means, what that testing true thing means, right? So let's look at the calculation you could easily do. What is the coordinates of this point? Anyone knows what I have here? What is the coordinates of that random point that I chose?
10, 0. 10, 0.
10, 0. 10 is the x, 0 is the y. Let's substitute that into this equation. So I'm going to write back the equation there. 60x plus 80y is less than or equal to 1200. 60x plus 80y is less than or equal to 1200. So what we substituted for x? 10. So it'll be 60 times 10 plus 80. What was y? Y is 0. Right? You could pick any point less than or equal to 1200. Let's see if this holds true. What is 60 times 10? 600.
600.
What is 80 times 0?
0.
So you don't even need to put that. And they say that this is less than or equal to 1200. Is 600 less than or equal to 1200? Less than or equal to 1200?
Yes.
Yes, right? So that is true. So that means that any point below this line would satisfy this inequality. So I would shade the whole region below this line. So let me begin that process. I'm looking at the time, guys. If you all could give me another 5 minutes, so just we might finish the whole question, but we'll finish most of it. All right, so I'm just going to put some lines to represent the shading portion here. So we are shading, right? Everything below the line. So that is the region of this line that is important. We're going to do the same thing now for the other equation. X is more than or equal to y. We could pick a point on top or on the bottom, but I would just stick with the same point here. Because let me show you again what it would look like. Let's look at the same point 10, 0. Can you agree that that point is this? Okay, with regard to this point, we could either shade down here or you can shade up here. You have one or two options to shade regarding this other line. The line of x is greater than or equal to y. You could shade either the bottom of the line here or you can shade the top of the line here. You all understand that, right? So we're going to pick a value either below the line or a value either above the line to test it. This value here is below this line, so we can use it to test this. So let's use the same value we have here to test if we shade the bottom or the top. Okay, that is what we're going to do. Let's just use. So the inequality is x is greater than or equal to y. So let's write that x is greater than or equal to y. What is x? X is 10 and y is 0. Is 10 greater than or equal to 0?
Yes, sir.
Yes, sir.
Yes. So that's also tested as true. So we know that we have to shade the underneath portion. You all understand what I am doing here? Let me know if you all don't understand. Huh? That is how we do these questions. If you're getting difficulties, you need to practice this. So I'm going to shade the bottom portion here now, right? So I'm shading this bottom portion here. Right, so that's the best I could do there. Right, so I know it's not looking too nice, but the point of the shading is for us to look at what the question asking us for. They want us now to label as R the region which satisfies both inequalities. What that region is the overlapping region. That overlapping region would satisfy both inequalities. Can you all see that this region down here is the overlapping region?
Yes, sir.
So that's what, right? And that is what we are going to label as R. I'm going to label this as R. That is the part. How to use black, right? How to use that darker point. This is R. Okay? So that is the 4 marks for this question. It's a lot of work, but I think it's a doable question if you practice inequalities. I think there's one more part. Now, this is a tricky little 1 mark to get. Let's look at this quickly before we end the period. This is the last thing we're going to do. Because this is the other part B here is really easy. It is, we'll spend like 10 minutes on part B tomorrow. This one wouldn't take us long. Actually, we could probably do it. We'll see. Let's just finish this one. This one is important for us to do. Right, so part B for this question, we'll do it tomorrow. It wouldn't be hard. This one will be real simple compared to part A. This inequalities portion was a little challenging. I understand that. The last thing with this inequalities.
A question.
Yes.
Right? Without doing the formulas that you just did or the process that you went through, couldn't you have just highlighted that section would be R? Because by looking at it, it does show that it overlaps.
Yes, but let's say we had shaded a different region, right? So it looks like it overlaps like that. That's good. But what if we had to shade the top region? Wouldn't this now be the overlapping region here? Let me try to draw it in with a thicker marker, black. Wouldn't this be the overlapping region if we had to shade the top? You understand why it's important we test it now? Because looks in this question, it could be deceiving. So you have to make sure you are shading the correct portions, because you could possibly be shaded. It could be any of these regions could have been shaded. Any of these regions could satisfy it. Okay, so that's a good observation, and I love that observation you made, because a lot of students might be wondering the same thing, and now they will get some clarification on that. Okay, so that's a good question. This is a little tricky question. So let's just quickly talk about this before we end today's session, right? They want us to know the total number of phones, mobile phones, is represented by X add Y. X add Y. According to the graph we just drew, what is the largest possible value of X add Y? Now, this question, what you need to do is you need to look at points inside your common area. So you see this region here, how it overlapped? We call that the common area because it is common to both inequalities. It's the common area. In order to do this part, you could pick points from inside here, and I will show you something, how to work this. Right, this one, let me just use a black point, a black marker. Let's pick this point here. What is the X value for this point and the Y value for this point? I know the point a little bad. 10, 10 and 5, right? What is it? No, they want X plus Y, so you need to add X and Y together. What is X plus Y there? 10 and 5 is? 15. Right. So so what you have to do is figure out where in this triangle you will get the largest sum of X and Y. And to be honest with you, in these types of questions, the largest area will always be either one of the corners of the shape. The largest value will always be one of the corners of the shape. So let's look at the three corners of this shape and try to figure out what this value, which one going to add up to give us the largest number. So let's start at the first corner down here. What do you think is the sum of X and Y in this corner here? Isn't it going to be 0?
Yes, sir.
So is that going to be the biggest?
Yes, sir.
No,
Well,
sir.
it wouldn't be the biggest, right? So it's 0, yes, but it wouldn't be the biggest for sure. So let's move on. Now, this point might be a little hard to see. And if you look at how the scale for this question was really bad and horrible, the first number is 0. So instinctively, students might want to put 1, 2, 3, but this is not 4. So it's a little bit difficult to interpret the scale. Indeed, every 4 represents 1. So if you count 4 blocks, 1, 2, 3, 4, that is 2. 1, you get the idea, right? So that is what this is.
Yes, sir.
Now, this point, if you go across here and you go down, it actually is between 8 to 9, right? And this one down here is also between 8 to 9. I wouldn't give you the exact value. We'll come back to this point very soon because I want to show you something. We don't even need to find that point. Let's look at the other point now. This is the one that I want you to focus on. What would be the sum of the X and Y coordinates of this point? X
20.
plus Y. 20. Now, looking at this one on top that I just drew, the one on top. If you add these numbers are both less than 10. Can you agree with that? One is between 8 to 9. If you add them together, would that be bigger than 20?
No, sir.
No. So you don't even need to bother worrying about that point. It is not going to be more than 20. So this number 20 represents the largest X plus Y value. Okay? So 20 add 0 is 20. So the X plus Y, we're going to stick with 20 for X plus Y is 0. Now, if you remember, X is the number of the B flex or B flow phone, and Y was the C flex or something phone, right? So I put in B and C. That means that with the money she had, if she bought 20 of the B-Flex phone and 0 of the C-Flow phones, and she would have ended up with the largest number of phones to leave the store with, basically, to buy. Now, the question, in my opinion, didn't have a condition that states that she have to buy any of this C-Flex phone. If we look at the initial inequality here, they told her that the number of B-Flow phones must be greater than or equal to the number of C-Flex, meaning that you could have more phones than C-Flex, but it never explicitly stated that you cannot have no C-Flex. Because if 20 is still greater than or equal to 0, it still fits the inequality. Hopefully you'll understand. Right, I'm looking at the time, but the answer for this is just 20 as 0 is equal to 20. Right, and no time run out already, guys. But that is basically the end of the inequalities portion. Just to talk you through Part B before we leave the session today, Part B is a very easy question where they give you some X and Y numbers here for a quadratic equation. All you need to do is plot it on this graph. They already plot some for you. When you plot the rest, the graph will basically take a U shape like this when you plot the rest of points. And they want you to answer 2 questions based on it for 1 mark each. Right, so we'll look at this one next day. It's very easy. You all could do this one home for next as well, and tomorrow we'll do it quickly. I won't spend more than 10 minutes on this question. It's very, very easy. So basically, this is the end of question 8. Right, we did a question 8 today. Tomorrow we spend a lot of time we're doing a circles theorem question, a vectors question, and a matrices question. And probably some multiple choice if we can squeeze it in, right? Hopefully. Right? Do we have any questions about today's class, guys? Hopefully it was informative and you all saw things that would benefit you in your future exam. Right?
Sir,
About
the one that we just did.
Yes.
When you chose a value, could you use like 20 on the x-axis and just say it would be 20 0, and then you would have 60 times 20 plus 80 times 0 equal 1200.
For this last portion here?
Yes, sir. So you could say 60 times 20 plus 80 times 0, you would get back the 1200.
Right. Yes, and that is good. Because remember, once we pick any value, any coordinate that lies inside this region R, it will satisfy these inequalities. That is the point of it. When we plot this inequality and this inequality, this region R is what satisfies both. So any point inside here, any point you want to pick inside here will result in satisfied inequalities. So you could have did that. You could have used that value, but you see, they didn't really want you to use this first equation here. But if you put the 0 and the 20, you say you're getting back the 1200. That's what you said?
Yes, sir.
Right, and that's satisfied because remember, this side would therefore be equal to 1200, and that satisfies the inequality still. So I hope you see that inequalities are it's kind of fulfilling when you kind of get it correct, right? But yes, that is good. That is a good observation that you made there, right? That is good. Do we have any questions again, guys? Let me save this.
Hi, good night. So I have a question.
Yeah?
So my question is, how often or how frequently do they put like standard variation questions on the past papers, or
like
was
standard
that
deviation?
Recent.
I believe that I never really did see that comment, to be honest. So that's why when I saw it, I had to give you all that to show you all that. I can't be too sure as to the frequency in which it comes, but I know that teachers don't really take that. I can't speak for other teachers, But personally, I don't really think it comes as often. So it might be a shock to some students. So I don't know. I really can't tell you the frequency. I can't remember how often I saw that. But I know from my initial shock when I saw it that it can't be something that comes often. And I'm pretty sure that you all did past papers in school and you may not have even encountered that as well. So it might be something relatively new as well that they included. I will need to consult more of the syllabus to double check that. Right, but it is certainly something that you should try to do. Okay? Try to understand that concept of standard deviation. I need to remember to upload this document for you.
Isn't standard
So
deviation?
what about completing the square?
Completing the square is, you see, vertex. You will use completing the square. You all know it have shortcut formulas for that, right?
Okay.
It has shortcut
Yes,
formulas for it. And if it's H and K, I don't know if you all know what what I'm
Yes,
referring
sir.
to, H and K. Yeah. If you don't like to complete the square, guys, use H and K, the H and K method. But yes, completing the square